to you or you're unfamiliar with strategic energy management, that's what SEM stands for. It is a capacity building program. So we are working with organizations in a cohort model. And participants in the SEM program are getting a dedicated coach, one-on-one coaching sessions every month, as well as asynchronous learning opportunities for skills building, and also virtual workshops. So cohort peers get together every couple of months for workshops to learn about various elements of energy management, and also to have the opportunity to do peer-to-peer learn about each other's challenges, what's been working, what hasn't worked. Energy managers and energy champions love to share what their failures have been and learn from one another. And so within a SEM cohort, that's all part of the capacity building. And along the way, we're working toward various milestones in the SEM program. So everything from building an energy team to building a facility baseline model, to come up with an M&V plan. I know that's what you'll be talking about later today. And then supported as well through 2 incentive streams. So participants in SEM can get incentives for performance. So we measure the cumulative sum of savings from your performance model, and provide 2 cents per kilowatt hour for savings that are achieved during the SEM program. It goes for each cohort runs for 24 months. So you have 2 years to achieve performance incentives. And there are also enabling incentives. So as I had mentioned, there are those milestones that we walk through with your coach and the activities that we do together. You can earn $1,000 per milestone that's achieved. So up to $5,000 can be earned toward the purchase of energy monitoring and measurement tools, which also kind of feed into what you're talking about today with your M&V planning. And the next slide. Just on the next slide, I was going to say on the people that participate in SEM in each organization, we do ask that you choose an executive sponsor and an energy champion. So the energy champion is the one who is most interfacing with the cohort itself and with the coach. Typically, the hours are shown there, both on the cohort activities and also the internal work that you're doing. The great thing about SEM, it's not an add-on to the work you already have. It's often just streamlining maybe the ad hoc energy efforts and projects that you're working on into a more strategic approach. So we are finding the feedback from participants so far has been that it's really putting the pieces in place and taking you to the next logical step. And on the next slide, just some numbers about how far we've come with the SEM program so far. We've launched 7 cohorts already for sectors. We have a multi-site portfolio cohort. We have a hospitals cohort. We have a colleges and universities cohort. We have a heavy industrial cohort. We have manufacturing cohorts, and over 80 participants. In fact, this week we just got 2 more, so I think we're sitting at 82 participants enrolled in the program, and excited to launch our next cohort, which will be the 8th cohort for municipalities, and that's going to be kicking off on May 14th. If you are interested, I highly recommend that you apply right now so that we can get to know you and get you onboarded into the program before that launch date. We will have 2 more cohorts before the end of the year. So if this timing isn't perfect for you, there will be a mixed sector cohort, but we're still encouraging you to apply as soon as you can so that you can secure a spot before the program is full. And just on the last slide here, I'll give you guys a chance to take a look at how to get in touch with us. So you can either email your questions to sem@iso.ca, or if you have the chance to pull out your camera phone and take a scan of this QR code, you can actually set up a 15-minute call with me or one of our coaches, and we'll connect with you and chat a little bit more on your individual questions. And that's everything I wanted to share with you, but if there are questions, perhaps we can take those in the chat.
Thank you, Christy.
My pleasure.
Now I guess we can start with Mylis.
Sounds good. Can you guys hear me okay?
Yes.
Okay, perfect. So I'm going to get us started with an introduction to MNV. Maybe some of you have watched the introduction to MNV webinar that is available on the Save on Energy training website. But if not, we'll go into a little bit of detail here to explain what is MNV, when it can be used for your energy efficiency project. We're going to talk a little bit about the 4 basic MNV methods or options and understand what are adjustments, which are a key point of MNV. And then Stephen will walk you through the usage of option C in the RETScreen software, where you can apply some of these MNV concepts fairly easily. So what is MNV? Here you have the definition that is widely recognized in North America, which comes to us from the IPMVP, the International Performance Measurement and Verification Protocol. This is the protocol that is used widely in Ontario for energy efficiency projects, and notably in the Save on Energy programs. So measurement and verification, which we usually call MNV, is the process of not only measuring, but also planning, collecting data, and analyzing it. So the goal of MNV is not just to get the data, it's also to get something out of that data, to verify and to report your energy savings when you implement energy efficiency measures. So this can have different implications. One thing that we like to mention is that MNV has a lot of advantages. I will just mention a couple here, but just know that these are not the only advantages that you will find by doing MNV. So of course, if you're not doing MNV, then you have no additional cost, right? Because when you start doing MNV, you're going to have some costs associated to that, whether it's for measurement equipment or it's for hiring people to do the analysis or even having that possibility in-house. So of course, if you don't do MNV, you're avoiding these costs. But on the other hand, you're not verifying your energy savings. So you can calculate them, but it doesn't mean that they're really happening at your facility. They are not, you have not verified that this is actually what happened when you installed the project. So MNV has many advantages, some of which are to potentially maximize energy savings. So by doing MNV, we're capable of measuring the performance of our energy efficiency measures. And what that allows us to do is to see if we're realizing the savings that we thought we would see. And if the savings are lower for whatever the reason, then we have a chance to go back in and make sure that we are maximizing these savings. We can tweak our controls. We can make sure everything is working up to par and ensure that we have maximized energy savings, but also better persistence in time of our energy savings. So when we're measuring during a longer period of time, for example, if you're measuring using your monthly bills, you can measure up to a year or longer if you would like the performance of your energy efficiency measure. That allows you to see if you have a degradation of saving with time. It's possible these things happen. Sometimes, you know, someone goes in, turns the measure off, or something happened and people need to be more comfortable and some of the set points are changed, but then they're not changed back. And so your savings are not persisting in time. But if you're using MNV and you're seeing that change in performance, then you can go back in and rectify it. So that allows you to keep the savings going through time. So these are just some of the advantages of doing M&V. So now if we look into M&V in a little more detail, there's a couple of definitions of terms that you're going to see when talking about M&V. So we're going to go through these. The first one is measurement boundary. So what we call measurement boundary is basically an invisible boundary that we are tracing around the equipment or building that is affected by the energy efficiency measure. We can decide how wide or how narrow that boundary is, meaning, for example, on this drawing, you can see we are measuring at the building level. So I'm just using the data from my my electricity bill to conduct M&V. But if I replaced something very small like lighting or a motor, I could just draw that notional boundary around that motor, around that lighting fixture, and just decide to measure what's inside of that boundary. So it's really up to you to define the boundary that works for you. And that can depend on a bunch of characteristics, like do you have measuring equipment? Is the project generating a lot of savings versus very little savings? That's going to impact the budget that you can put into going in and measuring that equipment. The second notion that we have here is around independent variables. So something that is very important to understand when we're talking about energy efficiency is that implementing the measure is not the only thing that can make your consumption vary in your building. There's a lot of other factors that mean that my bill from April 2023 and my bill from April 2024 are different, even if I didn't do any energy efficiency measures. So we can have, of course, the weather that typically plays a big role in that. So the outdoor air temperature is what we usually take into account. But you can have a lot of things. So in commercial buildings, in municipal buildings, you can have occupancy rates that can vary on a monthly basis, on an annual basis, etc. You can have also the behavior of people going into your building that can change. In more industrial settings, we can talk about production rates, so how much product is being processed, or product quality. Sometimes increasing the quality means increasing the energy consumption. And then something that can happen anywhere is equipment change out. So you have older equipment in your building that gets replaced, that's going to impact your energy use. So all of these factors will mean that your energy consumption varies regardless of your measure. And so we don't want to confuse the impact of these variables with the impact of our energy efficiency measure. So we need to find a way to differentiate the two when we do M&V. So what we usually do is we define what we call a baseline period, which is going to be the period of time that is before the implementation of your measure. And that period of time is going to allow us to take a snapshot, a picture of how the building or the equipment operates at that point in time, so that we can understand everything that happened before the implementation of our project, and we can compare that to the after period. So usually, once we have defined what that baseline period is, we want to collect information from that baseline period. So we want to know what was the energy that was consumed, what was the occupancy rate, what was the weather during that period, how many people were in the building regularly, or what was our occupancy rate in percentage, etc. So we want to create that picture of the operation of our building or equipment before we install something. Typically, we also have an installation period, so that's kind of our in-between period where we don't get to see much of the energy savings yet, but something has already changed. So when we start removing equipment, adding new equipment, or implementing these measures, we have that in-between period. And finally, the one that is going to interest us, because this is when we can calculate energy savings, is our reporting period. So the reporting period is once the measure is fully installed and fully operational, and it is delivering the savings that we are supposed to see. So we start looking at that period, comparing it to the baseline period, making sure that nothing else has changed outside of our measure implementation. And if something has changed, then we want to do some form of adjustment. We'll go into adjustments a little bit later, and then Stephen will walk you through some examples in RETScreen. But for now, just know that the MNV basically analysis is comparing that reporting period back to our baseline period and calculating savings from that. So to summarize this, we have this basic equation that we use in MNV, and it is also represented on this graph. This information you can also find on the MNV fact sheet that is available on the Save on Energy training website. If you want to have kind of a quick reminder of what we're talking about today, that fact sheet is a few pages, and it can really remind you of the main concepts quite easily. So to calculate the energy savings, we need to look at our baseline period energy, which is our blue line over here. And then we compare that to our reporting period energy, which is our green line on the right, our blue line, but on the right. And then we want to make sure we do our adjustments. So the adjustments is the fact of not just comparing the blue line before and after, but asking ourselves, how would my building or my equipment have operated if I had not installed that measure? Because some things may have changed. The main example that we use is weather. My baseline period and my reporting period don't necessarily have the same weather. Even if it's a few degrees changes, even if it's just the winter was a little bit colder, it can have quite an impact on that consumption. So we want to make sure that we are leveraging our knowledge of how this baseline was working with the weather, and then we adjust it to the weather of our reporting period, which means this adjustment is taken into account in that green line. And so our energy savings are basically this green line, which we call adjusted baseline energy, minus that blue line, which we call reporting period energy. I'm just gonna see if there's any questions at this point. I know I'm going a little bit fast over some of these concepts. I want you guys to feel free to ask questions through the chat or the Q&A. We can go through them either throughout the presentation, or we can go through them at the end. We'll have a 10-15 minutes to go through some questions. So continuing with that concept, now that we have defined all of these terms, some of the options that you will encounter are kind of names that you want to know, but they're specific to IPMVP. So the IPMVP, which is the most used in Ontario, defines 4 different options for MNV. And they're grouped into kind of 2 categories. One we call retrofit isolation, which is when I was talking about drawing that measurement boundary. Retrofit isolation means drawing that boundary really close to the equipment that's being replaced. So around just that motor or just that lighting that you're replacing, that means you isolate your energy efficiency measure from the rest of your operations, the rest of your building, etc. So it allows you to look at that measure really in detail. And that can be very useful when the savings of a specific measure are relatively small compared to, for example, your entire building's energy consumption. So that would just show up as noise if you were to look at the entirety of your building. But it can also be a little bit more costly because you'd have to install metering just around that equipment to know how it's functioning. So Retrofit isolation is separated into two options. We have option A or option B, and basically option A means you have to do fewer measurements, or you can measure for temporary period rather than longer periods of time. It's key parameter measurement. So you have to choose one parameter that's influencing your energy consumption. So it could be hours of use, it could be the amperage of your lamp or something like that. And that's just the one parameter that you measure. The rest goes through assumptions based on engineering judgment. Whereas for option B, you're measuring all the parameters. So you're going to want to measure your energy consumption, your hours of operations, anything else that would make your energy vary. So that's a little bit more involved, and usually you'd see that for bigger savings projects. So in industrial facilities for large motors and things like that would be probably a better fit. And then on the other end of the spectrum, we have what we call whole facility approach. So that's the opposite. It's like drawing that measurement boundary. Instead of narrowing it around the measure, we are this time encompassing the entire building. So you can do that through two different options. Option C, which is called whole facility, is when you're going to look at your electricity and natural gas, etc. bills, and you're going to leverage that to create a mathematical model of what's happening at your property. And you're going to use that to calculate your energy savings. Option D, which is very seldom used, I would say one of the main uses is in new construction, is a calibrated software simulation. So you have specific softwares like eQuest, CanQuest, or Hot 2000 that can create a model of the building, and then you would calibrate that to your utility bills and calculate savings for that. So today we want to focus on option C for a couple of reasons. One is it's usually not too expensive, because a lot of the data that we want to use in option C are electricity bills, our natural gas bills, the outdoor air temperature. This data is readily available. We don't need to pay or to install meters to get access to that data. So it's a fairly easy data collection process. And then there are also tools like RETScreen, which we're going to talk about later, that allow you to do that modeling of your building to understand, how is your electricity varying with the temperature. And that means that you can easily create something with option C and calculate your savings without having to do too much work. So if we talk about option C a little bit more, so option C, looking at our whole facility, so our utility bills, we're able to look at this data and identify the relevant variables. So typically it's going to be weather through the outdoor air temperature. But like I said earlier, you could also have things like occupancy rate that matter quite a bit in your building. So don't feel like you have to stick with just weather. You can define your own independent variable when you're creating this model, as long as you can collect the relevant data for it. So option C can be used, of course, when we have savings that are relatively large compared to the random variation that we would see in our bills. So there's a rule of thumb that I would say is around 10% of your total energy consumption. So if your savings represent more than 10% of your usage, then you should be able to use option C. There are more statistical ways of looking at it, but that's a decent rule of thumb. And so what happens with option C, we're developing what we call mathematical models, or usually regression analysis, to describe how our variables are explaining the variations in energy consumption. So in the absence of any energy savings measure, you would still have some variation. And so we're trying to correlate these variations to our variable. And just to kind of demystify this a little bit, For option C, you can use monthly utility data. You can also use daily data. You can use 15 minutes data. Whatever data you have available, you can leverage that in some way to create that model. Sometimes monthly data is going to be too little and it's not going to give us enough information. But sometimes, 15-minute data is a little bit too much and there's too many variation that we're not able to correlate to a variable. So it's good to find a little bit of an in-between and test it out at different levels if you can. I see that we have some questions in the chat, but I believe they have been answered so far. Stephen, did you want to chime in on the option D?
Just the distinction between option C and option D. I think option D is really preferred when you don't have energy consumption data before a retrofit. So an existing building without a meter, say as part of a campus, or as you described, Melis, a building that's being built. So in that case, you model after the retrofit, you calibrate to your post retrofit consumption, and so you have to add meters when you do the retrofit, and then you basically calculate your baseline going backwards and then compare the two. If you've got data, you always are going to prefer option C because it's a better and probably a less expensive route too.
Mm-hmm. For sure, yes. One thing to note is that
Melis, we also have a question from the Q&A. Mustafa mentioned it will be beneficial if you refer to the EPP, which is based on option C, and do all the required calculation and assessment through the EPP portal.
Yes, so that we will come to that in a little bit, since we are going to talk about the Save on Energy programs and the type of MNV that they require. So I'll get back to that in a few slides. Thanks, Mintu. Just going back to this option C versus option D, that's the other thing that Stephen was mentioning, is in terms of cost, option C is very light because you already have all of this information. Whereas option D, usually you need to hire an external energy modeler, someone that really knows how to use these software. So that can be a decent chunk of your MNV budget going to that person or that company. So it really depends on the route that you want to take, but usually option D will be more expensive than option C. So we're going to look in a very high level at option C, what kind of independent variables you can have. So I already mentioned weather. We can have outdoor air temperature, which can be correlated to heating degree days or cooling degree days, depending on if you're using electricity for both or just for heating or just for cooling in your building. We can also look sometimes at solar radiation. So sometimes the amount of sun that your building gets can impact your energy consumption quite a bit. So you might want to look into that as a variable. If you had some form of production in your building, so that's more for industrial, you'd want to look at production rate or product quality. So production rate being either in tons or quantity of piece of product. And then for everything, whether they be commercial or industrial buildings, you'll of course have your operation that you need to take into account. So sometimes it's the operating schedule. You could have a cleaning or a maintenance schedule. That means you have a reduced energy consumption. An annual shutdown, of course, is going to impact your energy consumption quite a bit. And like we mentioned earlier, occupancy can also have an impact on your energy consumption. So on the right side here, you have an example of a building's monthly natural gas consumption. So natural gas consumption usually can be correlated to two types of use in a building. You'll have heating and you'll have domestic hot water. So usually you can create a fairly simple equation that correlates your total gas consumption to your heating degree days for the heating portion. And then you'll have just a part that is fixed, and that's kind of your monthly or daily gas consumption for domestic hot water that you would find here. So in this case, we've already established that regression, And now we can calculate our natural gas consumption in a given month. So let's say February. If we know our heating degree days, we can just multiply this 682 by the coefficient 150 that we had established before. We add our constant value, and now we know that in this given February, with this type of weather, we should have consumed 116,000 cubic meters of gas. So that's just a quick example of how you can use option C to establish that regression and then leverage that regression to calculate your consumption given the independent variable. I'm just going to check for questions.
There is a question there
Yes.
about option B and option C. Maybe, Amelis, once I get going, if you want to, maybe you can type an answer to that one, because that could be a little bit involved,
Okay.
just for in the theme of time.
For sure. So I'll just go through this final slide before giving the control to Stephen for an example with RETScreen. But basically what we have in the suite of Save on Energy programs, so we've only listed select programs here, but you can see that in all of these programs, whether it's the existing building commissioning, the retrofit program, the industrial program, the energy performance program, the EPP, which Mustafa mentioned in the Q&A, and the strategic energy management program, which Christy talked about at the beginning of the hour. All of these programs can use option C. So it kind of depends on the project type. Of course, you're not going to want to use option C all the time for all of these programs. So specifically for the first three, it's very dependent on project type and size. But going into EPP and the SEM programs, this is something that is used for all of the project, and the model is developed through the ISO, through the Save on Energy portal. So for EPP, you can enter your data in the portal automatically. And for the strategic energy management, you would go through a coach to allow them to establish this for you. So that concludes our introduction to MNV, and I will stop sharing my screen and let Stephen take it over.
There we go. So I think you'll see my screen now, folks. And I've added one thing here. After this session, you can actually, I think there'll be a recording available, but also on RETScreen's YouTube e-learning site, there's in fact a 15-step video which walks through the example I'm going to walk through. So you can watch it in each segment. It's broken down by segment. Also, when we get into the software, in fact, there's what's called the video help. So you can hit a button in any part of the software and jump into one of these videos as well. So it's really set up for helping you to get going in it. Now, I could show you some slides, which I've actually prepared here, but I'm going to walk you through what's behind these slides. So these slides are here kind of as a placeholder. And ultimately, I'm going to get to the end of this, and I'm going to show you the M&V chart, and then I'll talk to you a little bit about what RETScreen is capable of beyond that. But what I'm going to do right now is I'm going to jump in, and I'm going to analyze the data set. This is the building in which there was a lighting retrofit conducted. And in fact, we really don't know exactly when the lighting retrofit was implemented, although we could ask people and find that out. So I'm going to show you how, if we're given a data set, what we would do to actually verify the savings and actually determine when the impact of those savings began. That's the neat thing about the approach we take here, is that it's actually gives you a bit of investigative ability as well. So that's the data set. It's a very simple spreadsheet. And actually, I think Mintu will send out that spreadsheet afterwards so people can then walk through the example and try it on their own. I'm a big believer in that. We're going to provide, for those that don't have a RETScreen license, we're going to provide a 14-day license as well, which you can use. Although you can try RETScreen out without a license, but you won't be able to save your file. So without further ado, I'm going to jump into RETScreen and just set it up from scratch and see if I can do this in 20 minutes. That'll be interesting. But I do have the finished product in the oven, meaning I do have a RETScreen file that's complete. So first thing we need to do is access some weather data. And when I say weather data, I mean daily data, because we actually have some consumption data on varying different monthly periods. So this particular facility is located near London, Ontario. So I'm just going to enter London, Ontario. The beautiful thing about RETScreen right now is that this allows you to access a lot of data relatively easily. So the building is up near the airport, so I'm just going to put my location pin in there, grab that location, and hit OK. So RETScreen has now locked that location in. Later on, when I go looking for weather data, which is different than the data you see on the screen. This is climate data, long-term average. When we go looking for weather data later on, we'll be able to pull that relatively easily based on the latitude and the longitude. So I'm going to do a facility analysis here, which is on a commercial facility. So I want to pick up a commercial institutional. It's probably an office building, so we're just going to leave the default picture here, but we can change that picture if we wanted to. Now, RETScreen can do benchmarking, feasibility, like what if you change this to that, performance, which is what we're going to do today, which is where we do the M&V piece. But I can actually simplify my interface by just clicking on performance. So I go location, the kind of facility, put the picture in there, and now I go to data. This is where I start to pull the data in that I'm going to use to do my verification. I'm going to bring in electricity consumption data. And I always suggest people use the predefined tables because RETScreen then knows when you use those tables elsewhere what are the columns, what are the units, and so on. RETScreen can, as Mail has talked about, deal with 15-minute data, 1-hour data. We call that sub-daily data. And actually, that's very useful in doing time series analysis, less useful in regression, which is what we're going to do here today. So I'm just simply going to go with the monthly data in this example, or I could use daily, but I'll be using monthly. RETScreen gives me the option of pulling it from green button, entering it, going to a CSV file. RETScreen also gives me the option of pulling it from other data sources as well. I actually have my house monitored by a system called Hydro, and I can actually pull that directly into RETScreen to do my regressions that way. But for today, we're just going to simply use the spreadsheet import that I showed you earlier. So I'm going to go and find that spreadsheet on my disk somewhere. So building 43, raw data, there it is on my desktop. I'm going to open that up. RETScreen is actually pretty good at interpreting lots of different data formats. So don't be panicked if you don't have it in exactly the right format. RETScreen is pretty good at figuring that out. So it asked me where the units are, where they're in the first row, and the data starts in the second row. Wants me to check the date format. That all looks good. So we're good. Now, we could do this multiple times, in which case we could append or clear and replace data. So if you modify your data, you can always bring it in again. You can deal with multiple sheets within a spreadsheet or multiple tabs within a spreadsheet. We just got one in this particular example. So it says, okay, I've looked at your data. This is what it looks like. You've only got one column here. So the default is to assume one column of dates. That's the end date. And it'll figure out the begin date if it can. Sometimes it's not perfect, and we'll see that. This is electricity, units or kilowatt hours. So it looks like it's got everything figured out. So I can go ahead and say, okay, pull that data into my sheet. All right, so it's pulled the data in. Here's the begin and the end dates. They're all there. Now, I didn't give it a begin date, and I can see how it calculated the begin date for everything but the first entry. For the first entry, it says the begin date is the beginning of the month, but we're looking at all these end dates. It's probably not. In fact, if you look at the number of days in the period, so we may have to go in there and do a little bit of an adjustment. So I'm going to go in there and I'm just going to adjust that first date to be the 15th of December. I don't know exactly when it is, but if I wanted to know, I would simply go back and pull that bill. But in this case, I'm simply going to make an estimate. And then at 15th of December, it puts 30 days in there. Maybe it's the 14th, who knows? But it's good enough for what we're going to do here today. All right, but the one thing that's really important is that these meter reading dates are what we want to use. And if you want to know why, is if you have 1 day difference in the month, that's 3% of the consumption in the month. And we don't want to see the date the bill was paid. We don't want to see the month for which the bill was entered. We don't want to see the end date in the month or the end day if it's the middle of the month like these ones. That can make a huge difference, and it can take useful data and make it into garbage, honestly. So how we treat those dates is critically important. Remember, we're going to go and get some weather data, and we need some dates for which that weather data applies. So in this case, the consumption is for these periods. Therefore, we're going to use those dates to get the weather data. All right, so we're all set here. The next step is to get the weather data. And so I'm going to tell RETScreen to go and get that data. From where am I going to get it from? Well, I can get hourly data if I want, but no, I don't need hourly data for this one. I just need daily data, and then I can line up the daily data to the monthly data I have here. So I go ahead and hit next. Again, I can connect to other data sources. If I got it in a SQL database somewhere, if I have my own weather station, I can pull it from other spreadsheets. I'm going to pull it from the cloud, in this case, downloading NASA data. So it says, well, you've got electricity data going back to 2009. That's the first date. Okay, so it's figured out what I need. Now I can make this a little bit quicker. I don't need to have right up until today, although it will bring it. Actually, let's just do that. It shouldn't take that long. And again, I can bring hourly data in if I want it, but we don't need that in this example. Boom. So we're going to sit here. We need the Jeopardy music, Melis. I see you've already answered some of the questions there, but yeah, so RETScreen takes a little bit. This works, unless, of course, the U.S. government is shut down, because it does rely on the U.S. website, and if the government is shut down, then sometimes the NASA site goes down, but it's been pretty good. So there's all our daily data. Look at that. All the data is there. Now, all you have to do is figure out how many degree days. Where are the degree days? They're not here. No problem. RETScreen has a tool for constructing degree days, right? And I like to use the max-min temperature method. Now, I don't know if I need heating or cooling degree days, but I'm going to do a little jump ahead. I do know that if I'm looking at this building, looking at lighting and electricity, I'm probably going to need cooling degree days. I can calculate both and just compare later on, but I'll show you how we verify that before we jump into our regression. Now, RETScreen wants to know what the reference temperature is, what the balance point temperature is between heating and cooling, when the building moves from heating to non-heating to cooling. Well, in this case, it's when it moves to cooling. I don't know where it is right now, but RETScreen has some tools to allow us to figure that out. So I'm just going to go with the default, say OK. Now RETScreen is going to calculate for me the cooling degree days. It's going to throw it in a column here over on the right-hand side. There they are. They're all 0. We got a problem? No, we don't, because that's January. If we go down here to the middle of the year, we'll start to see the degree days on a daily basis be non-zero. All good. Okay. So now the only thing you have to do with your calculator, you got to get your calculator at this point, because what you have to do is you have to go over to this sheet here where all the dates are, and you have to take the dates, and then you have to go over to the NASA data page here, and then you have to actually use your calculator to calculate all the sum of all the degree days. No, you don't have to do that. That's the way we used to do it in the olden days when I first started off in this business. But today we have a neat function in RETScreen. So we go to the energy table and we say merge. And what that will do is it will go and get, and what's it going to go and get? Well, it could get the average temperature, but I want it to bring the cooling degree days. So it's going to align all those cooling degree days with those dates, with the electricity. So now we have a data set that's properly conditioned. So we do that. Everything goes well. So there's our degree days on a month-by-month basis, but not the calendar month. This is the month for which we have dates. So now the energy and the weather, the driver data, the influencing variables are all perfectly lined up. Okay. So now we're going to move to analytics. So we're all ready to go. First thing I like to do is always do a quick little time series graph just to see whether my variables actually make sense. So I'm going to click in here. I'm going to pull in the electricity. I could look at demand too and cost, but I haven't done that here. And I'm going to draw a quick little graph here. And if everything goes well, we should see these curves synchronized, which they are. Like this is the perfect example right here where your peaks, right? But sometimes if the data you got given that you're driving in here into the electricity column, maybe you got the wrong dates, you're going to see these shifted. That's why I do a quick check here, because if I jump ahead and try to analyze data that's shifted, not aligned properly, problems. So I want to make sure it's visually aligned. But I could also overlay, if I had it, heating degree days, and I would see that the heating degree days would not apply in this example. So that's why I chose the cooling degree days. Okay, so now we're ready to do that regression analysis, that y equals mx plus b, the Melis showed us. All right, so I'm going to go in here and I'm going to select that I want electricity as the dependent variable, that which depends on cooling degree days. I'm going to go ahead and hit OK. And it's going to draw me a nice YX graph or XY graph, cooling degree days on the x-axis, electricity on the y-axis. Now, at this point, to be complete, I need to check to see whether this balance point temperature, this reference temperature is the right one for this building, okay? I could go and call the guys in the building and say, hey folks, when does your chiller come on, right? And when do you have to bring the chiller on? And they'll give me an answer. But what I'd like to do is I like to have RETScreen tell me what the answer might be first. So I'm going to set this down from 0 to 30. It's going to check all the temperatures and find the best fit between these two variables. And the best fit occurs at 12 degrees C, which is a long way off 18. And this will give you a much better answer. And if you notice, all those points are lining up around the line now, right? And statistically speaking, we have a 98.7% R squared, which means we're explaining 98.7% of the variation in this data set. But wait a second, this data set contains a retrofit. So somewhere buried in all this little variation is a retrofit. How are we going to figure that out? Well, we could go back and ask people in the building, first of all, what is the time when your chiller comes on? And if they say when it's around 12 or 13 or 11 degrees, then that kind of validates what we're finding statistically. But they may also, they could also say to us, you know, we did the lighting retrofit sometime in February in 2011, right? But we can let RETScreen tell us this. So what I'm going to do now is I'm going to take the technique that Mail has talked about. I'm going to use this line to predict what I would use each and every month, and I'm going to compare it to what I actually did use. And then I'm going to take the difference between those two and sum the difference. And that's the magic curve in all of this. It's called the Q-sum line, right? And when the Q-sum line changes slope in a major way, then I know something has changed in my building. So from this, I'm going to basically suspect that the retrofit took place in this time span right here, okay? So what I want to do is I want to find 12 months, and there's lots of reasons why you would use 12 months, minimum number of points, cycle of weather, all that good stuff. But I'm going to try to get 12 points before that change. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I can get 12 points before I think things really changed there. Now you go, Steve, well, something changed down here, and it may have done. And something changed here, and it may have done. But this is the most significant change on this chart. So that's my first candidate. So what I'm going to do is I'm going to leave this one here, which I like to call the overall one. RETScreen's kind of cool because I can then duplicate that. And now I can go in here and I can simply say, okay, I'm going to start on the same date, but I'm going to go for 12 months rather than all 48 months of data I have in there. Boom. There you go. Now, when I do that, I need to check my reference temperature because whenever we change data that we have in our regression, we need to go back and check to see whether that reference temperature, which it is still the same. Now we're explaining 99.54% of the variation. This is a pretty good model. So the information about the lighting retrofit was contained in that 1.5% variation that we weren't explaining originally. And now, statistically speaking, this is a pretty good model, right? And I know Mailus will appreciate this and others that are statistical folks out there, because I have statistics here which say the variables I'm using are significant. They're very big, much bigger than 2. And I have what's called a coefficient of variation of the root mean square error. That's your mouthful term for the day, right? But what that means is how much uncertainty is in the underlying data, about 2%. That means I actually can look for savings in this data set that are 2 to 3 times as big as that. So, Mailus, you mentioned 10% as sort of the rough guideline for what you can do with option C. But with this data set, with the underlying uncertainty being around 2%, I can probably go after 5% savings. And it turns out in this case, the savings are around 7%. And there we go. So I got a thumbs up for Mailus. She's my statistical reference point. So thank you for that. Okay, let's go and look at the Q-sum, right? There's the Q-sum. So the Q-sum says, hey, things were flat for a while and then they turn downwards, right? So if I get this Q-sum, what I'm going to do is I'm going to go back to the folks in the building and say, when was your lighting retrofit actually up and running? And I think it was up and running, basically everything was finished. So the reporting period should begin on the 13th of February. Here's my baseline period, and there's the period in between. Mail has talked about that, the baseline period, the construction period, and the reporting period. So I can actually go in here, I got a couple minutes here, and I can actually create a little diary. I'm going to create an event log where I can overlay some of these things. So I'm going to go back to 2011. Actually, my mind's not as, 2011 February. Yeah, so let's go back to 2011 February, and I'm going to put an entry in the calendar here. Right now, you can import lots of events into a calendar, right? So I'm going to and I'm going to go to the 13th because it has to be one of the dates for which I have data, right? And I'm going to make a green spot, so I got an entry. I'm going to say LED retrofit commission, CX, okay, for short. And I cursor out of that, it creates an entry. Now I can come back here and I can overlay that entry. So I can lay labels in this graph automatically, right? So I'm going to lay this one down. And it says, okay, that's when the LED retrofit was commissioned. So baseline, construction, and reporting period. All right. And this is telling me by the end of the data set that I have here that the cumulative sum of difference between the baseline period and what we actually consumed, right? So it's like Mail has said, that equation. I'm glad you showed that equation before because that's the underlying math. It's about 200,000 kilowatt hours. This retrofit saved about 200,000 kilowatt hours. Now, maybe you need to prove to others. And that's where a measurement verification chart comes in really handy. So the measurement verification chart, what it does is it takes the baseline period, right? And rather than summing the difference between the actual consumption and the baseline calculated sorry, the actual consumption, that's right, and the baseline calculated consumption adjusted for future weather, what it does is it shows me both of those. And it shows me the difference between the two. And if the difference is green, that's an improvement. The difference is red, that's a worsening. Okay, so my green line is almost always, except for over here, there's a little bit of red up here where maybe there was something happening there, and I'll get to that one. All right, so now what I can do is I can also say maybe I'm only interested in what the savings were for the first year after the retrofit. So if the commissioning date, well, what is the commissioning date? Well, I need to go back and turn on my event tracker. And I know my commissioning date was the 13th of February, right? So I can enter the commissioning date in here, the 13th of February, 2011, right? So we go with, and that would be 02, 13. And then I want to see the savings for 1 year, right? So then what I can do is I can then set this to 2012. I think I'll have to go to 2012-03. Sometimes it wants to snap to the, let's just see what it does. Yeah, it worked that time. I think that's 12 values. So the graph has to work in values that we have in the table down below, the actual dates. It can't go in between. So now let's just check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have too many. So I need to go back and bring this back to maybe go through 14. Let me cursor down on the table. 2012. So I need to go 0213, right? So let's try that one. That's the only tricky part, but there we go. So now we have 12 months, all right? 102,000 kilowatt hours in 12 months. And we can say that to a high degree of certainty. I'm going to tell you right now, without getting into how we do this statistically, there's about a plus or minus 20% uncertainty attached to that. And that's actually the most responsible way to report the savings, not just what you think the savings are, because to the uninitiated, that would look like you measured them right down to 1 kilowatt hour. But there is a plus or minus 20% on that. And that's always important and responsible to report it that way. And that can be calculated, as I mentioned earlier, based on the uncertainty in your baseline model. So, but that's a topic for a different day. All right, so we've gone through and we've done measurement verification as lighting retro. We can confidently report to our customer, our client, ourselves that we saved about 100,000 kilowatt hours, plus or minus. All right, so before I finish off here, I'm just going to go back and just look at a couple things. So there's our data set that we started with. We can do multiple projects, multiple actions in this. This was an example where we actually went back and we were working with a customer to do some work in the future, and we asked them for about 5 or 6 years worth of data. We discovered that over the previous number of years, between 2018 and the end of 2015, that they'd actually done a number of things. They had no clue about what they'd saved, no clue. So you can use it to verify savings for things you've done, or you can use it to reveal the success of what you've done in the past, right? And there we can correlate it to various different events that took place in the building. Now, the other thing that we can actually do as well is we can deal with what we call non-routine adjustments. And if you want to know what the massive non-routine adjustment that happened in the last 5 years was, guess what? It was a pandemic that meant buildings were going to be unoccupied. And we have to be able to adjust these curves. RETScreen can deal with non-routine adjustments in order to give a true reflection of the savings. Now, in this case, this was actually RETScreen's labs or offices down near Montreal. And there was an event that took place, which it was a piece of research that consumed significantly more energy for 1 month. And we were able to adjust that out and actually show, right, the savings for the project that took place back here at the end of the baseline period. So RETScreen has all the tools needed to even do non-routine adjustments. And there's about 5 different ways to do it. So if you're into that, have a look at it. And I think that is the end of my piece here today. So Mintu, I'm going to let you take the screen back, and thanks for your attention, everybody.
Thank you, Stephen. I think now many people want to use a RETScreen after that. We will definitely send the key for the 14 days after the webinar. So before I let you go, I just wanted to say that on Save Energy website, you can find multiple resources, webinars, fact sheet, MNV templates, and practical guides. Also, you have the opportunity to have a one-on-one coaching. I will send the link in the chat. And yeah, you will be able to ask questions about any project or about the webinars. So feel free to just complete the form.
A good example, I'm just going to interject here a little bit. A good example of that one-on-one coaching, maybe you want to see if this works for your building. Maybe you've got a building where you've got a bunch of energy data and you don't know whether there's been savings. Then we could actually use that one-on-one coaching to take your data, walk you through it, and leave you the RETScreen file that then you can then take forward and use for other purposes.
Yes, so if you like Steven say, if you have a project, feel free to reach out and complete the form. Before letting you go, I just want to say thank you to MOLAS for helping us promoting this webinar. I hope you enjoy. I think we have 2 minutes. If you have any question, Miley and Stephen are here. Christy also, and I saw Christy was replying to in the chat. So yeah, feel free to ask any questions.
There was a question about cost, and it's $869 a year. I believe it's for 10 users. I don't sell it, but let me just go back to the subscribe. I think the price should be in here somewhere. Yeah, $869. That gets you 10 users in an organization.
10 users.
Yeah.
Oh, so yeah, there is a question about RETScreen. What is the cost of having RETScreen,
Yep.
Stephen? I don't know if you.
That's the one I just answered.
Oh,
$869
it's
for 10
69.
users.
Okay.
Yeah.
I guess that's it. Thank you, everyone. And the next
Thanks, Chris.
webinar will be on wastewater treatment, the 4th of June. So we will wait for you for the next webinar. Thank you, everyone. Bye.
Thanks, Mitu. Thanks, Melis.
Thank
Christine.
you, Mylis,
Thank
Christy, and
you.
Stephen.
Thank you. Melis, I'll send you that file because it's a little bit updated. Okay.